What's up, everybody? This is the first Let's Go to Space podcast, version 1.1, because we had some technical difficulties earlier today. We have Grayson Huggins, a good friend of mine, classmate from Georgia Tech, and now a NASA JPL engineer. So, Grayson, why don't you introduce yourself a little bit before we get started?
Sure. Yeah. Hey, everybody. My name is Grayson Huggins. I'm currently a systems engineer at the NASA Jet Propulsion Laboratory. We'll probably call it JPL today, as it goes for short. Um, yeah. So I work on a lot of different space missions at NASA centers. I've worked on a couple in the past, and I actually met Warren at Georgia Tech working on, I think, probably our first both of our first space missions at Georgia Tech called Prox One. So yeah, excited to be here. Excited to be the first guest too. So thanks for having me, Warren.
Yeah, dude, we're super excited. We're super excited. So Grayson and I met back in 2017. We were working on the Prox One mission. I tell people it was a glorified space toaster that ejected a satellite built by Bill Nye the Science Guy, which is my only claim to fame to date. But believe it or not, when I go to classrooms and talk to kids, they still know who Bill Nye the Science Guy is. He's timeless.
Good. He should be timeless. He's like the best guy. I actually saw him in Pasadena like 2 summers ago. He came to
Oh,
talk.
no way.
Yeah, he was
Cool.
talking about his like planetary society. I think they're actually headquartered here, which is like the toast of the space toaster that Warren
You
was just
should
talking
you should
about.
try to get a tour because I know Swapnil, who worked on the satellite with us. He was in Pasadena at JPL and he was able to book a tour with them.
Really? Okay. Yeah, I'll definitely have to check that out once
Tell
this
him
whole.
tell him you worked on Prox.
I will.
Viewers, don't tell them you worked on Prox. They'll know you. They'll look you up. Not many people did, but so so Grayson, why don't you tell us a little bit about your voyage into college and kind of figuring out what you were going to do and how you ended up in the space industry as you are today?
Yeah, sure. Yeah, so it's definitely been kind of like a windy road getting here. It just feels like a lot of stuff has happened to get here. But I want to like first start by saying that like I know when I was growing up, I always like wanted to work in the space industry, and my parents definitely were like super into it when I was a kid. It was during the space shuttle era and everything, so they got me into it when I was like pretty young. And I know when I was growing up, and even when I like started college too, like it always seemed to me like okay, I want to work in the space industry, but like I never really knew if it was possible for me to do. I just felt like you had to be like born like understanding how to build your own computer and things like that. Like I didn't know how to do any of that when I was a kid. So like it always seemed pretty unattainable. But like I want to start by saying that like it's definitely attainable. I think for anybody who really has the motivation for it, to put in the hard work to do it, anybody can do it. So to any of you young kids or even kids just starting college out there, like it could be you for sure. Like so in terms of myself, I when I started looking at colleges and stuff, I wasn't totally sure what I wanted to do. I always thought, I wanted to work in the space industry, but again, thought it was completely like unattainable. So I looked at other majors, mostly engineering majors though, like chemical engineering and I looked at aerospace, I looked at mechanical, applied to a lot of different.
Chemical's pretty
Yeah,
specific. What was your motivation for that?
I don't know. I took AP Chem and I was like, it seems cool if I get to like be in a lab like mixing chemicals and stuff all day long.
Yeah, dude, that's
Yeah,
awesome.
yeah. So I
I
thought it was.
actually don't know anyone who did chemical. I don't know any chemical engineers.
I know a couple. Yeah, I know a couple. There aren't that many though. Seems like.
What do they? What are the ones that you know do?
Yeah, a lot of them are like petroleum like companies like
Totally.
BP, Exxon, all that stuff. Some of them are like pharmaceutical stuff. Like turns out
Okay.
like chemicals a lot more about like God, I'm not an expert at all. So if this is just botched, like I'm sorry, but don't mean to ruin your first podcast with some incorrect
No,
information. But
no, no. Call us
um,
out in the comments.
yeah. They'll just roast me in the comments. Um, I think it's all about like controlling like processes to make like, especially for those companies, to make like big batches of things, to make them reliably and the same every time. And you need a lot of background in engineering and chemicals specifically to be able to do that. So
Okay,
that's what
very
they did.
cool.
Yeah. Um,
So you were applying all these different
yeah.
majors.
Yeah. So I got into a couple different schools. Luckily for me, I grew up right outside of Atlanta, and Georgia Tech was super close and had the #2 best aerospace engineering school in the country. And I kind of decided at that moment, I was like, you know what? Space is like the thing I've always been like passionate about, even if like I've never worked in it or still feel like it's unattainable. I'm just gonna go for it. Like I'm just gonna absolutely go for it. And so I was like, I'm gonna do aerospace at Georgia Tech. I'm gonna stay close to the parents. Actually ended up being sweet. They did
Oh
a lot of
wait.
my laundry and stuff, which was sick.
Okay.
But what?
Sorry, I lost you on the headphones like blooped for a sec, but we're all good.
Sorry, what did I last say?
Um,
Are you listening, Warren? Oh my god.
no, I was. I freaked out because the audio cut out.
Oh
Um,
no, I'll just start. I was saying I wanted to really go for it in terms of working in space. I wanted to just do as best I could. So I chose aerospace at Georgia Tech, aerospace engineering, um, and I was just taking classes, like every college student does. But I decided, I wanted to try to start getting involved where I could. So I heard about this mission called Prox One, aka Space Toaster, and I got involved like literally the second semester of my first year in college, and I worked on it. It was really really cool to like get to work in a clean room for the first time and all of that. It was just stuff that you see in the movies, you see in like documentaries and stuff. That's what it felt like to me, at least, even though it was like this small lab at Georgia Tech. Um, but that blossomed into like an internship in the aviation industry for a semester, and then I'll never forget the day I got my first call from a NASA center, which happened to be JPL, saying like, "Are you interested in like possibly coming to intern here?" And I couldn't like respond fast enough to that. It was like dream come true.
so
So
for kids getting into the research, how did you get into working on Prox One?
yeah, so yeah, it wasn't as hard like as it might sound. I feel like what you what I really did was, like I said, I wanted to go into college and really just like go for it. So I went for it. I talked to professors that I had classes with. I met kids that were a grade or two above me in college and saw what they did. And when I did that, I happened to talk to one of them who was on Prox One, told me about it. He was like, "You should go talk to this professor." And I did. And turns out professors aren't scary, and they're not like, "Oh, we need to review your resume. We need to go through this app." No, he was just like, "Yeah, let's do it. Let's have more people involved, and you could be one of them." So again, it comes back to like really just going for it. I think if you're into aerospace, STEM, and really any career, it's what you want to do. Just like you have the motivation for it to really just give it your all. Just see where it takes you, because it could take you to the highest peak that you like never thought you could reach. And if you don't get all the way there, you're still doing a great job, and you'll do amazing things regardless. So
Yeah,
one piece of advice that I
I think I'm gonna harp on what Grayson said a little bit. I think when I went to UGA before I got into Georgia Tech. I got denied from Georgia Tech. I got denied from other schools. The only school I got into was University of Georgia, and they don't have like a prolific engineering program. And I found a group of kids who were building a small satellite research lab. Small sats being satellites like the size of a loaf of bread or about this size. I have a
oh.
big head, so the scale doesn't work perfectly, but it's like if you had a box around a softball. But I started talking to my professors freshman year, and I'm like, how can I get into space things? We don't have aerospace engineering at UGA. How I want to build stuff that goes to space. What are there people doing that? And I got introduced to the UGA small sat research lab, and I applied to that group, and I interviewed with them, and their interview was kind of intense actually, and it wasn't all about technical stuff. I think, and to this day, when we run interviews for that lab or for other labs, or if I'm looking for interviews for my nonprofit, when I interview people, I I ask some technical questions to see like what the ground is, but it's all about the passion behind it. Do you truly want to do this? Is it a resume line, or is it like you want to send something to space? Because I had no technical skills whatsoever. I got interviewed. I'm like, I can't. I can't tell you that I can do that. I just can't. But I can tell you, I can promise you that I will learn how to do it, and I will do it well. I'll do whatever it takes. I'll be there. I'll commit. And for Grayson, similar experience. And when I transferred to Georgia Tech, I kind of had to do the whole process again to start working on the satellites there. I talked to them and I really committed. And I think if you can show your motivation and passion to learn, it goes miles longer than knowing equations off the top of your
For
head.
sure.
And that goes for job interviews, that goes for university interviews, that goes for project interviews, things like that.
Yeah.
So I think that's very important. But beyond Prox One, what did you get up to in college, or what other internships did that lead to?
Yeah, sure. So, yeah, I spent my first internship. I spent a semester up in Cincinnati, Ohio, at GE Aviation, working on like jet engines for planes and stuff. So I was kind of, I've always been kind of like mechanical focused. So I was working on like, kind of the nuts and bolts of certain parts of the jet engine, which is really cool. And I also did it for like 5 months. So instead of like, just like a 10-week summer internship, I did it for like a little bit of time, which taught me a lot, technically, but also like, how you like maneuver yourself kind of in the workplace and things, and how as like a young budding engineer, how you can like show your passion to people and all of that. I thought that really taught me a lot, and I wasn't expecting that out of that internship. At JPL, my first summer, I got to work immediately on like the coolest mission I could have ever thought of, which on Europa Clipper, which is it's this mission that JPL is sending to Jupiter, specifically the moon called Europa. And Europa is really cool because they think that there is a like it's surrounded by ice on its crust, but they think there's like a liquid water ocean underneath that crust. And where there's liquid water, temperatures are warm enough for a lot of for possibly for life to form. Some scientists think that life got started near these vents in the ocean floor and stuff in a liquid water ocean. So scientists think that Europa could be a place where life exists in our solar system. And the fact that you know like we're sending something there to like investigate that, I just think that's like the coolest thing in the
It's
world.
so rad. It's so
It's so
cool.
it's so cool. It's so cool.
And something. Oh, geez, shook the whole desk. Something that's I think is awesome now, and in the grand scheme of things, is I think a bit crazy to think about. Is just we think that there's great potential for life on Europa, and I don't know if it's what moon it is, but Titan 2 or wherever Dragonfly's gone.
Enceladus. Titan too, but Enceladus is like
Titan, Enceladus, where like there are the building blocks of life here. It's rad. And then Mars, the huge proof for life existing there. And now with the recent news, Venus too, right?
oh yeah.
Um, is there anything NASA's doing with Venus currently? Any missions in the
Um,
work? I know
there's a
Cupid's Arrow.
yeah, there was that one. I think some people at Georgia Tech were working on that.
That was Terry. Terry was working on
Oh,
that for sure.
yeah. I wonder. Yeah, I wonder how he's doing.
We'll get him on the podcast. We'll
Yeah,
get
maybe
Terry on
he'll
the
come.
podcast. That'll be
um,
rad.
that would be really cool. Yeah, you probably reach out to him and see. Anyways, there's actually so NASA has like these a couple different levels of like missions, and it's really how big they are and how many people go towards building them and stuff. And there's a lower tier, I say it's still a lot of money, type of mission that's like it might get approved. It made like the finalist round to go to Venus. I think it's
Oh,
called
awesome.
Da Vinci, I think is what one of them might be called. There's
That's a
pretty
cool
cool,
name.
but I don't know enough about them to like actually talk about them right now.
No worries. So, for the projects you're currently working on, you worked on Europa Clipper as an intern for
Yeah,
your first round. What did you intern again at NASA, or
yeah. So the first summer I worked on Europa Clipper, which was I still can't believe I worked on that. It's so cool.
what you do for Clipper?
So for Clipper, I worked on so I worked on the cables that go between electrical boxes on the spacecraft. It sounds kind of like, oh, here's an HDMI cable. How great is that? But like
I
Jupiter
know
has,
all too well
oh,
about
I know
harnessing,
you
man.
do. For those people who don't know, it is a very big challenge, and the whole especially at Jupiter, another thing that's cool about robotic space exploration and just space exploration in general is every place you go has its own challenges that you've never seen before. Jupiter, for example, is huge, but it also gives off a ton of radiation, and that has like, and because Europa is really close to it, like that makes the engineering even harder. So I had to tackle things like that. I also did a little bit of mechanical design, and a part that I designed got workshopped more and more throughout the years, but it's flying on the mission now, which again, I think that's
That's
the coolest thing.
gnarly.
Um, and and you can do that. Like literally, if anybody has the motivation for it and puts in the work, like that's what you can do with your career. And I'm just so blessed to like be here, like talking. There's so many like things that I'm just so happy have happened. But anyways, um, the next summer at JPL, I worked on a different mission called SWOT. No, it's sounds pretty cool, but it stands for Surface Water Ocean Topography. And
That's
so,
I like Earth science, man.
yes,
Don't
yes, yeah.
bash Earth
No, no, no.
science.
It was actually awesome too. And what I was going to say is one thing that people don't realize is that a majority, or I don't want to say a majority, but a very big portion of NASA's budget goes to Earth science and not like
I would say
just
most
studying.
of it.
Yes, it might be most of it, honestly. And because people, the big like the Mars rovers and stuff, they make the news because you're going to Mars, right? But a lot of our satellites that we send up to space actually look back at Earth and solve things like climate change, and the way your phones work and weather works and all of that is because of
Mhm.
satellites that are in space
Yeah.
focused on our planet. And so it was a different type of mission, and it's really, really, really cool. So you're not just going up into space to explore everything. All this stuff is cool. I think it's the
Yeah.
most. Um,
You
so
don't
that
have
one,
to lie to me. You can say Earth science isn't as cool as Jupiter. That's fine. It's whatever.
I got to spend a lot of time in the clean room on that role, though, which a big clean room now this time instead of Georgia Tech's clean room is great, but it was cool being in like the what they call the high bay at JPL. It's where they build all these multi-million, if not billion-dollar missions there, which was great. And now I'm on a mission called Psyche. Psyche is going to an asteroid in the asteroid belt that's a little bit different than others. They believe it's made entirely of metal, so no rock or anything. When you think of an asteroid, you probably think of very rocky. This one is literally made of like solid metal. And what's cool about that and unique is that they think it could have been the core of like an early planet in our solar system that maybe had its crust and outer layers like thrown away
That's
by
cool.
impacts or something. And so what's cool about that is we're exploring this other world, but it could tell us a lot more about our own planet and how other planets form. And leading into that, like how does planet evolution lead to the right conditions for life and things like that, right? So we're building the building blocks of how did Earth form in the first place? How are we here? Things like that. So you're answering big questions by doing small things along the way to get there. So
So what exactly did you do for SWAT going back to that, and is that any different from what you do now for Psyche as well? What do you do for Psyche?
yeah. Oh, I got to talk about lunar flashlight after this. Don't let me forget.
Oh yeah, yeah, yeah. We'll go
Yeah.
back to lunar flashlight. For people who like the moon, stay tuned. Don't
Oh
or skip ahead 5 minutes. But
yeah. The moon's really cool. Yeah, I love the moon. Anyways, yeah. So I got to spend a lot of time working on one of what's called a subsystem in a spacecraft. Typically, you'll break up parts of a spacecraft into different like smaller parts of it. Like the computer for the spacecraft is a subsystem. The solar panels that you see is a subsystem, right? So I worked on actually this mechanism. It's pretty much a piece of like a I don't know how you would describe a mechanism.
like
Just something
like
that
a
you
part of a
know
robot, like
part of
a robotic arm is a mechanism on a big human robot, right? And so
exactly, yeah. So it was like a big robotic arm that deployed the solar panels. Because one thing that's tough about launching stuff is it's really cool. They have to like fold it all up together to launch it, and then they make it unfurl. So I worked on like the unfurling part of it in space, and I because of that, and they had all the hardware. I got to spend a good part of my summer just like in the clean room with the real hardware that was going to space. It hasn't launched yet. I think it's launching next year. but yeah, so that was my second summer there. I did that for like 10 weeks. And then I got an offer to start at JPL now. And what I'm doing is kind of totally different than that now.
Really?
Um, yeah, yeah. What I'm working more on like how the computer talks to the actual hardware and makes it work. Before I've done a lot of like mechanical, like nuts and bolts stuff. This is a lot
That's
more.
super interesting.
Yeah,
What
yeah. It's
what do you think caused the jump from like very hardcore mechanical to you're figuring out how computers talk to one another?
yeah. Well, first off, there's it's always good to be learning. Um,
Yeah, no,
so
always go
yeah,
for it.
it's like it's like you can focus on one specific thing for a really long time and become like the best at it. And the flip side of that is you can focus on a lot of different things and learn a lot of things along the way. And so I'm 23, just started my first job, right? I don't want to, I want to see a lot of different things before I figure out which path I directly want to go down, right? And so this is like a 180 of that, right? So it's like, now let's see the completely different side. And what is there a happy medium? Is there, do I like one side better than the other? It's always good to be learning new things. And I think as like an engineer, that's what your job always will be as an engineer is you're always going to be learning new things. So
That's super cool. So in between these internships, so for everyone, Grayson did his bachelor's and then went straight into his master's. So when you were doing your master's, for a lot of people who don't know, master's degrees are 2 years compared to the bachelor's four. Sometimes, if you stay at the same university, do your master's, you can do an accelerated track. But most of masters allow you to specify more on what you want to study. So while our aerospace bachelor's was we're going to get a bit of circuits, a bit of mechanical design, we're going to talk about aerodynamics, we're going to talk about a little bit of space design. In your master's, you can pretty hone in more and more on a subject matter you care about. And so, Grayson, for your master's, what did you study specifically, and did you have any projects or thesis related?
yeah, yeah. So I stayed at Georgia Tech for my master's, and I decided kind of I wanted to jump into the mechanical design part of it. Like Warren said, we got a little bit of everything in undergrad. Got the fundamentals of everything we need to know to go for it. And I was like, well, I want to know a little bit more about like this one thing, or a lot more about this one thing, and not so much about everything. So I focused on like the rocket engines, the what's called propulsion in the space world. I'm also in the aircraft world, and the mechanical design aspect of it. And because of that, I actually got to work on another NASA mission run by JPL called Lunar Flashlight. So I spent like my full year of my master's on it. Learned from one of the best engineers I've worked with before, Don, and who's at
We'll get
Space.
Don on here too in the
You should get
future.
Dawn on here too, for sure. She taught me a lot. She was further in her master's, taught me a lot, and then I took over the project, led it till I left. But Lunar Flashlight was, instead of one of these big spacecraft like Clipper or SWAT or even Psyche, um, this was a CubeSat scale. So a CubeSat, Warren, if you want to show that thing again. Um,
Boom.
Boom. That's one CubeSat. That's like what's called a 1U CubeSat. So if you can imagine six of those, three of them stacked up and two wide, that's a 6U CubeSat. And that's how big Lunar Flashlight is. So it's like a briefcase. That's or like a laptop or something.
Yeah.
Um, and what's really cool is we're getting to the point with some of the technology that's being built in space that we can start miniaturizing these big, huge spacecraft into smaller packages, into CubeSats. And that's really the goal of a lot of people of CubeSat development, is because you can build them pretty quickly. They don't cost as much money because they're not as big. Um, but recently, because of like in the past, they've kind of been limited to just flying around the Earth because they can't go as far as bigger spacecraft that have these huge engines on them, right? So I worked on the propulsion subsystem of Lunar Flashlight. And what's cool about it is because of something called additive manufacturing, which we can talk about if we want to jump into it.
Yeah, for
Um,
sure.
but because you can start 3D printing stuff, you can start shrinking the size of these big rocket engines down to really small sizes and using them on CubeSats. And because of that, we're able to actually go to the moon on lunar flashlight, go into orbit around the moon, and do like good science that scientists want to get, um, literally at the size of a briefcase. So it's a really cool mission. I got to design a lot of parts on it and like lead the project for a little bit on the Georgia Tech side, not on like
That's super
Marshall and
cool.
JPL, but super cool stuff that like they entrusted to like a 23-year-old in college, right? And
What's the project's goal? Sorry to cut you off.
yeah, yeah, sure. I guess I should have led with that. Thank you.
Oh, no, 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 that's fine.
So it's going to use our propulsion system to go into orbit around the moon. But what it's actually going to look at is like the craters on the south pole of the moon. It gets really cold there because there's not as much sunlight. So what they think is that there's water trapped there in the form of ice. And they think there are pockets of water ice scattered along these southern lunar pole craters. And what's great about that is, water's good. There's not much water in space that we know of, so having it, well, actually, there's a lot, but there's not much water
Close
readily
by.
available. Yeah, close by. That's a good word. So when we send astronauts to the moon, do we want to launch them plus, 500 gallons of water, or do we want to launch them with less water and then they get the water that's already there on the moon? You can use that for feeding and sustaining humans for long-term stays. Another cool thing is you can use it to create rocket fuel from water, which is really really cool. And so then you don't have to bring the rocket fuel with you to the moon when you go. You can bring other stuff. You can bring more food. You can things like that. It's the whole resource like battle in
Mhm.
space. So having those resources available to us and knowing where they are with missions like lunar flashlight is really important for the next step that we take to go back to the
And this is a huge overarching theme in space technology, human space flight, and space travel these days, and for the future, because um, the hardest part, the most expensive part of going to space is launching, is getting all of that mass, all of the material, all the supplies off of Earth. And so, if we could use the moon as an outpost, the moon has much less gravity. If you can use water, ice on the moon, to turn it into rocket fuel and use the moon essentially as a gas station, you can propel yourself much further into space than we could ever do before. And um, the same thing with getting astronauts oxygen, getting astronauts water, and something that's been going on for the Mars rovers as well. The Mars 2020 rover, which just launched in July, I think, or the end of
Yep.
June. It had a payload on it, a payload being this big block of science,
Mhm.
investigation, technology, that's taking Martian air and trying to convert it at some rate into water or breathable air for future humans. And so it's a test of a small technology that they would in the future scale up so that we can survive on Mars without bringing our own oxygen and air, which, like, if you don't have to bring all that, you can bring way more food, you can stay there longer, you can bring more science technology to do more research. There's a bunch of stuff. And also, there's been a couple companies that have started. I think both of them have been acquired or went under by now, but with mining asteroids as well, right? Asteroids are big and rocky, but most of them have these huge iron cores, like planetary cores, full of nickel and iron, gold, diamond, whatever you can think, ice as well. And so there's going to be some industry with taking all of this material and putting it towards longevity for humans or other space missions that are already in space.
Yeah,
But
for sure.
with that, what based on based on your work and what you've seen through your studies and currently at NASA and your past internships, what are some problems you see in the space field or the space industry that you're kind of excited to work on or think about?
Yeah, for sure. And I think, what you just said really like leads really well into that because that is one huge problem that we're like trying to solve on a day-to-day basis. But there's like seven other huge problems too. And that's why like the space industry needs like budding young engineers to start in the industry. That's why, I really appreciate what you're doing, trying to like inspire the next generation of engineers. It's awesome. We need more people like you, Warren. This is so sick. Um, because
Thanks,
like
man. I appreciate it.
because there's so many like things to try to solve because we're trying to go out into space where we've never been before, but we have to bring Earth with us everywhere, especially when we take humans, right? We have to bring all of that stuff. So the resource utilization is like one aspect of it. The other aspects of it are, I'll start with, you talked about the Mars 2020 rover. That's actually a JPL rover. JPL has built all the Mars rovers to date. Um, so Curiosity is currently running around on the planet right now, and 2020 will be there soon. It's called Perseverance. So it's going to land in February. But one of that instrument you were talking about is called MOXIE. There's a lot of other instruments there that are there to lay the groundwork for a bigger mission called Mars Sample Return. So what's cool about Mars Sample Return is the Mars 2020 rover Perseverance has the first like coring drill that's built to take samples of like the Martian crust and store them away in these tiny little tubes and leave them there so we can go pick them up and bring them back to Earth later. Um, so why would we want to do that? Why don't we just take the instrument there? Well, what we've been talking about. It's all about a resource, right? You launch one instrument, it means you can't launch another instrument. So there's only so much you can do. What we can do though is use an instrument like a big drill, pretty much the robotic arm drill is what it's called, to take these samples and then launch another mission to bring them back to Earth. And once we have these samples of Martian crust on Earth, we can send them to the best laboratories in the world that have equipment we couldn't dream of sending to Mars anytime soon to do investigations on. Example of this: say we take a coring sample that they call them, and investigate it with two of our instruments on the Mars 2020 rover, and they come back. They're testing like a specific chemical composition or a specific gassing product or something, right? I'm not. I'm just kind of listing what.
And all of this is to look for signs of life and essentially these tiny fossils
Yeah,
on Mars.
exactly. So that's really what it comes down to with a lot of robotic space exploration, of solar system exploration, is discovering either how, if there's any life anywhere and how it started, or where could have the possible conditions for life that we should explore more. There's a lot of other things, but that's one of them. But 2020, the 2020 rover has that goal as well. So thanks for mentioning that. I definitely should have started with that. If they looked at this core sample, but they only checked a couple things about it, they might say, oh, there's no life here. However, you could bring that back to Earth and they could check it for something different and find the life. They could find something else, right? There could be a different signature that we didn't predict in the future to be there, that we weren't expecting, that we would find on Earth. So we would have assumed with the first example, oh, there's no life in this sample. But you bring it back to Earth and you figure out, yes, there is. Wow, if you think about one of the biggest discoveries in human history, finding life on another planet besides Earth, that's a pretty big one.
That's
So
rad.
it's super cool. And I know a lot of people at JPL who work on it, and it's one of the cool things we do. So there's that side of it. The other big side is by a company called SpaceX and Blue Origin, and a lot of other things, a lot of other launch vehicle companies that are starting. SpaceX, I feel like, is really leading the effort right now. But one thing we've talked about, costs a lot of money to go to space. Why? Because it costs a lot of money to build a big rocket to launch your very expensive satellite into space and make sure it works every time, right? So what SpaceX is trying to do is bring that cost to get into space, that barrier of entry, down to where more people can start launching whatever they want, CubeSats, things like that, right? And so they do that by reusing their rockets. Elon Musk has a good example where he says, imagine if you flew from New York to London, threw away the 747 airplane that you flew in, and then flew another one back. Like that's how much money those things cost, right? Like
Yeah.
it's not very economical. So they're trying to solve that issue of let's reuse the rocket multiple times. We save a ton of money, and so that's a huge part of it too. And all these things are kind of working hand in hand together. They all need to work together to enhance space exploration. So
I like I'm gonna take that analogy even one step further, right? So SpaceX is doing exactly that. They're making sure they're not tossing away this multi-million-dollar vessel to bring things to space. But the things going to space, right? If you have a CubeSat, these things still cost like anywhere between 50 and a million, 50K to like $1 million, depending on if it's one of these, or if it's six of these, or 12 of these, or if they're going to the moon and need a ton of technology, or if it's just a radio kind of bleeping like Sputnik.
Yeah.
Um, but but the reason that these smaller satellites, CubeSats, can typically launch cheaper is because they're like Uber ride sharing the space version, right? And bigger, more expensive missions from NASA or the government or European Space Agency, JAXA, the Indian Space Research Org. They're launching big weather satellites. They're launching the Mars rover. They're launching missions to the moon, that sort of thing on these rockets. And these are $100 million missions to $1 billion missions. What do you feel like with uh, the reusability or the extension of life for satellites or rovers? Have you thought about that at all?
Yeah. Yeah, that's a whole other thing. I honestly don't know too much about it, but it is pretty important. As an example, like the GPS satellites that are up there, like our DirecTV satellites. I think they recently like repaired one, anyways, um, or some other satellite. I don't know, but they go up there and they're up there for 20 years, but eventually they're gonna stop working. Things degrade over time, even in space. It happens in space too. So, do you a um, send up a new satellite every time one of these things dies? Sure, it might not be that often, but there's a lot of them up there. So, are 10 going to die in the same year and you have to send 10 new satellites that cost $500 million a piece? Or do you like invest in a whole infrastructure of smaller satellites that can go up there and fix the problems and, be done? Might cost a lot more money up front, but like you extend the lifetime of these satellites, like you said. I think it's really cool. I don't know enough about it to talk intelligently about it at all,
It would be
but
cool. Oh yeah, I'm totally just guessing on it. But like, you're launching these really expensive missions that have a lifetime of like 4 to 12, maybe 20 years. But 20 years is like a long time for a satellite. And then near the end of their life, they just kind of push them out of the orbit into this graveyard orbit where other alive satellites don't go. And then they send up another. And to my knowledge, I know Orbital ATK, which was bought by Northrop Grumman, was doing the mission extension vehicle, the MEV, to put more
yeah,
fuel in satellites. But I'd be pretty interested to hear about like, what if a payload breaks in this old satellite? Can you repair the payload? Or if you're on a satellite with multiple payloads, like a lot of weather satellites, can you take one out and put a new one in or something like that? I think that sounds like a cool
yeah.
field.
That's really it. It's like you ever seen those videos like when they replace like the Hubble mirror? Like,
Yeah, so this is some good background. The Hubble Space Telescope has, I mean, probably the most famous thing to go to space that's not a Mars rover, right? We get all the pictures of deep space from Hubble. It originally had an optical error because they couldn't account for weightlessness. That's a weird word to say. Weightlessness when on the ground. They didn't account for it, and the optics had to be so aligned that gravity deformed it. And when they launched it and went to space, it was a little off. And so a company called Ball Aerospace made a contact lens, and then astronauts went on the space shuttle with the contact lens, flew up to Hubble, put it on, and repaired it, and it was able to function. Like, I don't know how long it's been in service now, definitely 20 plus years.
for sure.
But I'm sorry, I totally cut you off. What were you gonna say
No,
about?
no, no. That's like a great like I'm glad you said that's perfect. 'Cause it's like the Hubble. What's cool about the Hubble is it's literally like at the same orbit as like where the ISS is, like where we send people. But like these weather satellites you're talking about are thousands of times further away than Hubble is. So we couldn't right now we can't even think about sending astronauts up there to fix it. So like you have to do it with like robots to do it. And technology is progressing pretty far right now. So I feel like we're getting to a spot where we can start thinking about doing that. I'm sure people are working really, really hard on that right now. But Yeah, so that's just another good example of like a really hard challenge in space. Um, One thing that I'm like kind of excited about is the other challenge of like, well, what happens when it's not just the United States going up there and, you know, like putting flags on the moon and stuff like that? What happens when there's other countries? And I don't know. This is just my 2 cents. I'm 23 years old. I don't know anything, but I think companies like, or not companies, countries work together really, really well in space, and people don't really realize that. I think when you start going up there where it's literally like, oh, between me inside my spacecraft and like a couple inches of aluminum is like vacuum cold space, I die in like 15 seconds, right? Terrifying. But so when you're up there, like all of the stuff, all of the issues we have on the ground and stuff kind of go away, and you start just working with people together as like human to human. And I think, it's a nice anecdote or nice thing to think about with all the craziness going on in the world right now. You just start seeing people as like, I want to work with you to make sure we do the best we possibly can on this
Yeah,
and take the next step as a species. That really like excites me. I think that's a really cool part of it that people don't automatically think of when they think of like space challenges. But I think that's a really cool like side to it. I hope I'm
I
right.
think I think no, no, no. I think that's awesome, and I think it's to become an astronaut and to for countries that aren't on like great terms. You know, you're on the ISS with Russia and the USA, Italians, Koreans, Japanese people, like all these different ethnicities and backgrounds, and uh, I mean, you have to work together, like for the progression of humanity, for the survival of yourself and your friends with you. And there's a great quote from an Apollo astronaut who went to the moon. I think it was an Apollo 18. I'm not sure, but he said when you get up this far and the moon, or when you're on the moon and the Earth is just the blue marble. It's there are no borders. You can't see any borders. You can't see a difference between any people. He said, you just want to grab a politician by the collar and bring him up here and say, look at this.
Yeah.
And I think that's completely true. We all get caught up on things that are smaller than what humanity is as a whole. Um,
Yeah.
but
We're capable of doing like a lot more when we work together, I think. I think that's like a
exactly,
positive message that people
like
should.
there's NASA missions with payloads from the ESA, which is the European Space Agency. There are ESA missions with payloads from JAXA and NASA. There's the Canadian Space Agency, which contributes also. It's like this big happy family, and it's really all just to progress the understanding of humanity and knowledge and the pursuit of information about the universe.
Exactly. Yeah.
But with that, my final question for you for the podcast today is what are what are you most hoping to see in your lifetime happen in the aerospace or tech industry?
Yeah. That's a tough question. I feel like I'll start that with another thought, and then I'll get back to it.
No,
I
that's
feel like
fine.
right now is like one of the best times in history to get involved in space exploration. Like I feel like okay, the Apollo era was pretty awesome. Like I don't know if we're topping that quite yet, but we're getting to like literally there's so many things happening. It's I work for NASA, but like NASA's not the only dog in town anymore. There's a lot of other companies that are trying to get involved in this, trying to build their own satellites, trying to do that. It's not the same as it was back then. And so that being said, like the space industry needs like a lot more people interested, growing up, like excited about it. Like, I grew up with the space shuttle, but the kids that are growing up right now never haven't even seen anything launch from American soil until SpaceX did it this year, right? So I haven't seen
Hmm.
people. So, we're missing that side of it, but there's so many things happening and there's so many problems to solve that we can start solving now because of where technology's that I'm really excited for what's going to happen. And I think there's a lot of things that are going to happen that we can't even think about right now. I really hope, right? But I think the thing that would make me most excited is obviously landing a person on Mars would just be the wildest thing ever. But before we do that, we got to go back to the moon. We got to prove that we can do it for a long period of time because the moon's in our backyard, but Mars is on the other side of the other side of town. Like it's like we need to prove that we can do it on the moon. and send people there reliably, and then we can go, okay, let's send people to Mars. Let's start building the infrastructure for like not only just one time go and come back, but like building a colony there, building like the first planet colony. That's like it sounds like science fiction, but we're getting to the point where we're starting to lay the groundwork to do that. So I think it could happen in our lifetime. Um, do I think it's going to happen in the next 10 years that we send somebody to Mars? I don't think so. I hope I'm wrong, but I think we're going to send somebody to the moon in the next 10 years. And if that doesn't inspire like a whole, like the Apollo missions inspired us, and we grew up in, the late 1990s and early 2000s, and it was 40 years before we were born or whatever, 30 years. So imagine what's going to happen when we do it again. So
I think, yeah, Artemis 2024, here we come. It's going to be the renaissance and the new age of space. I'm super excited.
I'm super excited too, man. And again, props to you for doing this. This is super cool. And by the way, he's got an awesome lineup of people coming on the podcast, and he's trying to grow it more and more. So share it with your friends and all that stuff, and get this guy rolling.
I love it. Well, thanks for hopping on, Grayson. I appreciate it a lot. And Ad Astra.
Ad Astra.